All right, so today we're going to start talking about compound inequalities. So we are opening to page 6 of our packet. So once we're at page 6 of our packet, there's a spot for you to put the definition of a compound inequality. So a compound inequality is a sentence with two inequality statements joined by the words and or. Okay, so again, a compound inequality is a sentence with two inequality statements joined by and or. Okay, so if you see there's like two different parts. It says and versus or. Today we're just going to focus on and. So right there where it says and, you can write down what and is an inequality where both statements are true at the same time. So again, an and statement, both statements are true at the very same time. So if we look at the example in our packet, we see three number lines. The first one says x is greater than or equal to 3. So I'm doing that one in a magenta color. So I'm going to close my circle because it's including 3. I'm going to draw my line this way. I know my lines aren't good, but it's going to be okay. That's our first one. Our second one says x is less than 7. So I'm doing that one in a blue color. So it says x is smaller than 7. So I go over to 7. I'm keeping it open. And it's all the numbers that are less than 7. All right. So our last statement, we should know that the way that we are thinking about this always is x is between 3 and 7. Okay. And if we look at this right here, we're going to just combine the two things. So if I basically just draw these graphs down here, again, so it's x is less than 7, and now my purple one is x is greater than 3. So my and statement, if we look again, it said that it was a statement where both things are true at the same time. So we're looking for numbers that are smaller than 7 and greater than 3. So really, if I wanted to draw that inequality all together, I'm going to just do it in this color green. It's where they overlap. It's where they overlap. So it's this graph right here, where we have it's between 3 and 7. That is what an and statement is, just this green part right here. Okay, so that's what we're going to be working on. So if we look at our examples in our packet, we have 2. We should see the first one looks like negative 2 is less than or equal to x minus 3 is greater than 4. All right, so we should recognize this as x minus 3 is between negative 2 and 4. That is, again, how we're saying it. We're not thinking it as negative 2 is less than or equal to x minus 3 is less than 4, because that's not how we would speak in everyday language. All right, so there's 2 ways to do this. The first way is we're going to set up 2 inequalities. So this is my first one, because we know that 2 is smaller than x minus 3. And our second inequality is x minus 3 is less than 4. So these are my 2 inequalities. And now I'm going to go ahead and I'm going to solve them. So if I wanted to get x here by itself, I would add 3. And so negative 2 plus 3 is 1 is less than or equal to x. Okay, so we know x is definitely going to be bigger than 1. If I go over here and do this second inequality, I add 3 to both sides to get x alone. I get x is less than 1. And I realized now that I made a mistake because 4 plus 3 is 7. So x is less than 7. So again, this is an and statement. So both parts need to be true. So we're looking for numbers that are bigger than 1 and smaller than 7. So the way that I'm going to write that is the way we've done things before is we put the smaller number here, we put our bigger number over here, put our variable in the middle, and we put less than signs. Okay, then we see do we need the or equal to it all, and we need it over here. So my answer to this inequality, the solutions that will make this a true statement are numbers that are between 1 and between 7, or between 1 and 7. If I wanted to graph that, I could set up my graph. If I have a 1 here, if I have a 7 here, we know that we will close the circle at 1. We'll keep the circle open at 7. Should probably just change my color. And it's all of these numbers here. So possible solutions include 1, 2, 3, 4, 5, 6, and then all the fractions that are in between. Okay, so that's one way of doing it. I do just want to show you another way, because some people like it, is if I have negative 2 is less than or equal to x minus 3 is greater than 4. You can keep it all right here, and to get x alone, we would add 3. And so if I'm doing this over here, I need to do it over here, and I need to do it over here. So I get negative 2 plus 3 is positive 1 is less than or equal to x, which is less than 7. See, I did my addition right there. All right, so this right here tells us that x is between 1 and 7. Again, it would have the same graph over here where I have this 1 closed-in circle, open circle at the 7, and it's everything that's in between. This is another way. The thing to be careful about is if there was a coefficient in front of this x, that again, you would divide everything by all the sides. So it's just important that whatever you do here to get x alone, you do here and you do here as well. So this is one way, and here's the second way, is breaking it up. All right, so we have one more example that we'll do all together. So it says 6 is less than r plus 7 is less than or equal to 10. All right, so again, the way that I'm thinking about this in my head is that r plus 7 is in between 6 and 10, including 10, not including 6. So if I wanted to do this either way, so the first way I could do 6 is less than r plus 7. So that's my first inequality. Or I could do my second inequality, which is r plus 7 is less than or equal to 10. So I want to get r all alone, so I subtract 7 from both sides. And so 6 minus 7 is negative 1 is less than r. Over here, I'm getting r alone, I'm subtracting 7. And I get r is less than or equal to 3. So I have a compound inequality. I have two statements that need to be true. It's saying that r needs to be bigger than negative 1 and r needs to be smaller than 3. The way that I write that is I put my small number here, I put my big number to the right, put my variable in the middle. We always have less than symbols. And now I put my or equal to sign over here. If I want to graph that, we have negative 1, we have 3. I'll make sure I change my color this time. So r is any number that's in between here. So this is going to be an open circle at negative 1 and a closed circle at 3. So all the numbers in between here. So our possible answers could be 0, 1, 2, and then all of those, and 3, and then the fractions that are in between them. Okay, so that's one way to solve it. Again, we also could solve it if we had 6 is less than r plus 7 is less than or equal to 10. To get r alone, we got to subtract the 7. We got to do that on both sides. So we get negative 1 is less than r is less than or equal to 3. Gives us that graph there. Okay, so again, just to sum up, a compound inequality is a sentence where you have two inequality statements, either joined by the words and or. We only focused on and today, and means that you're going to have two statements that are both true at the same time, so it both needs to be true. The one last thing that I want to talk about is if you have an and statement where you have no solution. So this is not in your packet, but if you were to have something like negative 4 is less than or equal to x, which is less than or equal to negative 10. All right, so here is an and statement, right? It says that x needs to be between negative 4 and negative 10. So it needs to be bigger than negative 4 and smaller than negative 10. So if we look at a number line, is there a number that is bigger than negative 4, so it's over here, and smaller than negative 10? No, there is not. So it's important that when we solve inequalities, we really think about what it's saying. So if you were ever to come across an answer that looks like this, you would say no solution. because no number can be bigger than -4 and smaller than -10. Okay? All right. Have a good weekend.